Gentlemen, this is Miss Humbert here. So today we're going to be talking about secants and tangents. So first of all, let's talk about what a tangent is. So tangent is a line that intersects a circle at exactly 1 point. Okay, so remember that that is called the point of tangency, which I have circled right there. Also recall that the radius is perpendicular to the tangent. So if we have a radius extending out this way, then that's going to be perpendicular to that tangent, okay? We were using that in previous note sheets to find right angles of triangles, and so that's something we're going to be using moving forward as well. So that's just a reminder of tangents. Next, let's take a look at secants. So for secants, what you need to know is that secants are going to have a line that intersects a circle at exactly 2 points. So what you notice about secants is they're entire lines. They're not just segments. A chord is a segment that stops at the edge of the circles. Whereas these two, they intersect at 2 points, but the lines keep extending on after that. Okay? Next, let's take a look at this first theorem here. If a secant or two chords intersect at the interior of a circle. So what does that look like if they intersect at the interior of a circle? So we have two secants or chords. They could also be chords. And let's call this A, B, C, D intersecting at point E. The measure of the angle formed, so the measure of angle E, let's do X right there to make it easier. So that angle right there that we're using, so the measure of angle X is going to be equal to 1/2 the sum of the arc AB, and this is in degrees, and arc DC, again in degrees. So you're taking 1/2 the sum of those arc lengths. So let's go ahead and let's put that into practice. So first of all, for number 1, okay, so I notice that I know the two arc lengths associated with these angles. Okay, so to get that interior angle, all I have to do is take 84 plus 130, and then I'm going to divide it by 2. So it's always important on these that you add the top first. So 84 plus 130 is 214. So then you're going to take that answer and you're going to divide it by 2. So then 214 divided by 2 is 107. Okay, so then that's going to be the degree measure of this interior angle right here. Okay, let's take a look at number 2. So for number 2, again, we need to look at this exterior angles, and then that's the interior angle associated. So again, we can take 76 plus 88. We can take that and divide it by 2. So 76 plus 88, that's going to give us 164 divided by 2. So then we're going to take that angle measure right there and divide it by 2. And that's what's going to give you that interior angle. So you end up getting 82 degrees for that interior angle by just adding the sums of the arcs and dividing it by 2. So if you take a look at this one, so for the angle X, we actually don't know the arcs associated. We need to figure that out. Well, what I notice is that this right here forms a line. So going from here to here is 143. So to get this little bit, or dB, all we have to do is take 180 minus 143. And that's going to give us 37. Same thing for this next part. We only know this little niblet here. So to get that in a little niblet there, we need to take 180 minus 75. And that's going to give us 105 for that arc length right there. So now we're ready to solve for X because we can take this plus this. So we can do 105 plus 37 and divide it by 2. So we're going to take 135 plus 37. When you do that, you get 142. And you're going to take that and divide it by 2. And then you need to get 71 degrees when you calculate that one out. So let's take a look at number 4. So for number 4, now we don't know one of our arc lengths. So we're just going to put that into the formula. So here's what I know. This plus this divided by 2 needs to add to that. So X plus 97, divide that by 2 is equal to 110. So now we need to get that 2 over to the other side. So I'm going to go ahead and multiply both sides by 2. So I get X plus 97 is equal to 220. When I multiplied by 2, that crossed those out, so I was just left with this on top. That's why I did that. So the last thing I need to do to solve for X is to subtract 97 from both sides. So 220 minus 97 is going to give me 123 degrees. So it's 120 degrees for that arc length there. Next, let's take a look at number 5. So for number 5, it's going to be the same kind of deal. This arc plus this arc divided by 2 adds to this arc. So I'm going to have 25 plus my x. Then I'm going to take and divide that by 2, and that's going to be equal to 25. Okay, so now I need to get that divided by 2 to the other side. So I'm going to go ahead and multiply both sides by 2. So then I get x plus 25 is equal to 25 times 2, which is going to be 50. Or not 25, sorry. This should be 60. Okay, because that was the interior angle. Silly me. So then 60 times 2 is going to be 120. So then I'm going to take 120 and I'm going to subtract 25 from both sides. And when I do that, I end up getting that x is equal to 95 degrees. So the degree of that arc is 95 degrees. Next, let's go ahead and let's take a look at this last theorem here. So this theorem says if a secant and a tangent intersect at a point of tangency, then the measure of their angle is 1/2 the measure of its intercepted arc. So what does that mean? That means that the measure of angle, if I could select a pen, that would be most helpful. So the measure of angle 1 then is going to be 1/2 the arc AB. Likewise, the measure of angle 2 is going to be 1/2 the arc BA or BCA, because we want to tell it that we're going all the way around that way. So let's go ahead and let's take a look at some examples of these. So for number 6, it wants us to find QPR. So what is QPR? QPR is this angle right here. So I know the intercepted arc. So all I have to do is take the intercepted arc and divide it by 2 by that theorem. So we have 148 divided by 2, and that's going to give us 74 degrees. So the measure of that angle right there is 74 degrees just by what we know about the intercepted arc. Next, let's take a look at number 7. So for number 7, I know that this angle right here is 64, and I want to know the measure of the angle DEF. So I have to come up with a couple things first. First, I want to find out what the arc FD is going to be. So to find out that arc length, all I have to do is take that interior angle and multiply it by 2. So that's the reverse of the theorem we just did. So we have 64 times 2, and that's going to give us 128 degrees. So this guy right there is 128 degrees. Unfortunately, that's not the arc we want to know. We want to know the arc length of that larger arc. Well, thankfully, we know that circles add up to 360 degrees. So we can take 360 and subtract the arc length that isn't included. So we're going to take 360 and subtract off 128. And when you do that, you get 232 degrees as your final answer for number 7. Okay, lastly, let's take a look at number 8. So we want to find RQS. Oops, marker here. We want to find this angle measure right here. We know that QTS is 238 degrees. So the next thing we need to do is we need to figure out the arc length that's actually involved with our angle. So we want to figure out the arc length of QS. So to do that, we're going to take 360 and subtract the angle measure that was given to us to get that other arc. And then we end up getting 122. 122 goes here. Now remember, to get that angle measure, it's going to be 1/2 of the intercepted arc. So we're going to take 122 and divide that by 2. And when you do that, you end up getting 61 degrees for your intercepted arc. So that concludes your note video today. Thank you for listening, and you can go ahead and get started on your practice sheet once you are done.